Hi, Charlie, and welcome to Only 5 Minutes. Charlie, your gravity-based storage technology operates in the 1 to 20 megawatt capacity range. Why is that?
The physics of the system isn't constrained in any way. We can lift a very small weight. I can lift a coffee cup and I'm storing some energy and it can come crashing down. Or we could build a system with 10,000 tons. It's probably the maximum-ish for a single weight system. We believe 1 to 10 megawatts is a commercial sweet spot. So we're not looking at kilowatt systems, looking at megawatt systems, and we are a grid scale distributed energy storage company. And for individual shafts, 10 to 20 megawatts is probably the max per shaft. If we want to have a system that operates for more than, say, 15 minutes, if we want to store a 100 megawatt system, we could sink 10 shafts next to each other or 5 shafts next to each other and maximize that power. So one of the benefits of the system is that it's very versatile. We don't actually have hard constraints on either power or energy.
Can you share some tech specs with us?
Typically, we're talking individual weight units of around 500 to 600 tons. And in a typical European shaft, that will give us about a megawatt hour. So if that typically is what the unit is. Our system is modular, and each individual system will typically have 4 winches, and each winch will typically have 4 motor generators. So you can stack that system up any way we like. Cables are steel cables, multiple cables and from the multiple winches, partly for redundancy, but partly also for controlling that system. And a big part of our IP is in the control system of how to operate multiple systems. And one thing that people don't realize often is the winches aren't concrete lumps. A 500-ton concrete lump is a very difficult thing to handle and deal with. It'll almost certainly be a bucket filled with a heavy material.
So how difficult is it to construct such a system, and what are the locational constraints?
Initially, we'll be deploying projects in existing mine shafts. So the constraint is where there happens to be a deep underground mine that is either coming to end of life or has a disused ventilation shaft, for example. Even in those projects, the challenges, we have challenges as an early stage company to develop the mechanical system, the winch and the power electronics, and configure it and put it together. But we need to demonstrate that. We're very confident in what we're doing, but we need to build them and get them to market. There are always challenges around the civil engineering, whether that is taking an existing shaft and making it suitable. That is it can be a high cost activity and it can be a very low cost activity. So there are challenges around the risk of cost overrun in that. And if we're sinking new shafts, we'd be talking depths and dimensions that are relatively easily done, if you like. It's civil engineering rather than mining engineering. So we'd be talking shafts of 200, 300, 400 meters, not of a kilometer. But it's still a major engineering project. So on the civil engineering side, again, it is around control, us having a very good relationship with the contractors. And as we grow and as our capacity to build projects around the world grows, it's all around the ability to do civil engineering works.
So how long would it take you to build, say, a 10 megawatt system?
For these first projects, we're looking at an 18-month development time, which we're well into, and an 18-month build time.
And in future?
6 months and 6 months. So about a year from commissioning or to commissioning from decision to build.
What further characteristics make your technology stand out?
The storage duration is a choice. We can have a very high power system that operates for 15 minutes, or a lower power system or lower max power system that operates for 2, 3, 4 hours. We believe we can build a system that does 8, 12 hours plus, but we don't see a hard commercial market for that at the moment. And in other specs, efficiency, 80% round trip. So more or less as good or better than any alternatives, significantly better than pumped hydro, about the same as lithium batteries. Speed of response, sub-second. And that's very important for us. We really have some of the good characteristics of lithium batteries in speed of response, controllability, but some of the good characteristics of pumped hydro in terms of extreme durability. And that's our our sweet spot, our unique selling point is that the cycle life is 75,000 cycles plus, and the project life is 25 years at least, if not 50 years.
Finally, how does your gravity-based storage solution compare to lithium-ion batteries in terms of levelized cost of storage?
Levelized cost of storage is one of these difficult things to calculate. It does depend on what sort of applications you're modeling. But in systems where you're modeling a decent lifetime, so 15 plus years, and at least one cycle per day, we look very competitive with lithium batteries and flow batteries for that matter in any other comparable technology. If you have more cycles per day, then our levelized cost looks very good. So our lifetime cost is very low. It depends also obviously on what your discount rate is. If you value the future, if you have a relatively low discount rate and multiple cycles per day, then our system looks very much cheaper than lithium batteries or any other technology that we know about that we can seriously look at.
Our time is up. Many thanks, Charlie.